Hi guys, welcome to my channel. Today topic is semiconductor as devices. So this is the fourth topic in chemistry of materials. In previous session we already discussed what is semiconductors and how they can prepare in different ways. So and today before going to semiconductor devices we need to know the what is PN junction diode. So silica is a pure intrinsic semiconductor material. It doesn't have any impurities, so when you contaminate the pure silica metal with 13 group elements like 15 group elements, then it will become as a extrinsic semiconductor. For example, when you dope it with the phosphorus, it is a 15 group element. It possesses a excess electron. This because of this electron, it gets a negative charge. This is called N-type semiconductors. And when you dope the pure silica metal with the boron atom, like 13 group element atom, it has a positive hole. It is called p-type semiconductor. So like that we can generate p-type semiconductors and n-type semiconductors. So but the thing is, when p-type semiconductor and n-type semiconductor are placed together, then the physical boundary between the p-type and n-type semiconductors are called p-n junction diode. So when you move the p-type semiconductor and n-type semiconductor close together, there is a junction between physical boundary between p and n-type semiconductor. This boundary is called depletion layer, and this device is called p-n junction diode or p-n junction semiconductor. So this can be represented as like this in this symbol. So this is also in our devices, they will represent it like this strip mark as a cathode. Okay, you can see here how p-n junction diode formed. It is a p-type semiconductor. Majority of positive holes is there. This is a n-type semiconductor. Majority of electrons is there. When you are combined each other, so there is a transition between p and n-type semiconductor. In between, positive holes and negative electron combined each other and forms a depletion layer. There is no charge, but some of the electrons are moved towards the p-type semiconductor, forms a negative layer. Some of the positives move towards the n-type semiconductor and forms a positive layer this side. So this is the p-n junction diode. This depletion layer is called p-n junction diode. But you need to observe the thing is, at the p-type semiconductor there is a negative layer is there. At the n-type semiconductor, at the positive layer is there. That was the very important thing when you consider the p-n junction diode. Okay, so next one is, so how this p-n junction diode act as a rectifier. What is rectifier? Rectifier is a device, it's a semiconductor device which convert the alternative current into direct current. Okay, so before going to rectifier, we need to know the what is alternating current and direct current. Okay, alternative current voltage will changes over the time. For transport the electricity from long distance, we generally use the alternative current. So alternative current voltage will changes. It's touches the maximum edges, and it also frequency touches the lower edges also. So this is a over the time, this current voltage continuously changing over the x and y axis. Okay, so but it is not suitable to maintain a electrical operator at home. We need to convert this current into direct current, which is moving in a straight way, one way current. Okay, that is called direct current. So to convert this alternative current into direct current, we need a device. That device is called rectifier. So how semiconductor diodes, PN junction diodes act as a rectifiers? How they convert the alternative current into DC current? So if you look here, so when you construct a PN junction diode as shown in the diagram, so see here, so this is the P-type semiconductor. So number of positive holes is there. So this is the N-type semiconductor, number of electrons is there. When you combine each other, there is a depletion layer formed. At the p-type semiconductor, negative electrons layer is formed. At the n-type semiconductor, positive holes is generated. This is the p-n junction diode. Now you need to connect p-n junction diode to battery in such a way, n-type semiconductor to negative terminal of the battery, and p-type semiconductor to positive terminal of the battery. See here. So now when you on the switch on the battery, when you pass the alternative current through the battery, so what will happen? You are giving electrons in the direction of negative. You are giving the electrons like this way, but already so many electrons is there. So many electrons is there. You are also passing electrons here. So if you pass the electrons with more force, passing electrons will move this electron into forward direction, right? Now what will happen? This layer will move this side. Okay. So look at the next this side. So you are connected the p-type semiconductor to positive holes. That means positive charge is applying on the p-type semiconductor. Because of repulsion forces, all positive charges move towards the forward direction. So because of this connection, so this PN junction diode, PN junction depletion layer size is decreasing. It is become as a thin layer. So when it is become as a thin layer, electron easily jumps from n-type semiconductor to p-type semiconductor in a single way. So this is the one way. So when you connect PN junction diode in such a way, n-type semiconductor to negative terminal, p-type semiconductor to positive terminal, then alternative current which is passing through the battery can be converting into direct current. It will pass in one direction. There is no alternating waves. There is no change in the direction. There is no change in the voltage. Like that, we can convert the alternative current through the connection of PN junction diode in a forward bias. This connection is called forward bias. And so there is a, you can see here. So when you are passing electrons, this depletion layer is almost decreased and disappears. So you see here, you are passing electrons from n type, and that means n type semiconductor is connected to negative terminal. That's why electrons is coming. Electrons is coming. So when you are passing electron, this depletion layer size is decreased. Okay. So the same way, if you go for the reverse bias, that means n-type semiconductor connected to positive terminal, p-type semiconductor connected to negative terminal. What will happen? Because of this positive charge here, electrons is there, electrons and positive charge are attracted each other. That's why this depletion layer moves opposite direction. So here also same, like depletion layer moves different direction. Now deflection layer size is increasing. Now it is act as a insulator. It will not conduct electricity. So when you connect PN junction diode in reverse bias, it acts as a insulator. When you connect the reverse bias, when you connect the PN junction diode in a forward bias, it will help to convert the alternative current into direct current. This is the rectifier, so which convert the alternative current into direct current by using PN junction diode when they are connected in forward bias. So next one is PN junction diode. Same things, how forward bias and uh, reverse bias are connected each other. Next one is semiconductor act as a transistors. Before going to transistor, have a look on tap which is used in our homes. So tap taking water from the tank. So this is the collector. It will collect at this point, water is collected from the tank, and this at this point water is emitted to outside. And another thing is there, that is the base. This is the base. By using this base, we can give the full flow of water from collector to emitter, or we can stop the water. We can completely stop the water from the collector to emitter by using base. And also we can operate the flow of water by using base. By controlling the base, by giving the how much water we required, we can control the flow of water by using base in between collector and emitter. If you apply the same principle in the electronical devices, that is called transistor. So it is a p-terminal semiconductor device which is used as a conductor or insulator based on their arrangement. It is a semiconductor device. If you see here, P and P, so three semiconductor, p-type semiconductor, n-type semiconductor, and other p-type semiconductor. One p-type semiconductor act as collector, one p-type semiconductor act as emitter, and another one act as a base, just like tap. So it is just like a sandwich type of materials. So one n-type semiconductor sandwiched between two p-type semiconductor, it is called pnp semiconductor device. So if you observe here, one p-type semiconductor is sandwiched between the two n-type semiconductor, it is called npn transistor. You can show here like this here. One is act as a collector, one is act as a emitter, in between base is there. The composition and arrangement, based on the composition arrangement, they act as a insulators or conductors, and also they can adjust the flow of electricity. So that's why they are used as a switches in electronic device. That means off and on, that means they can flow the fully electricity or they can fully stop the electricity. That means fully act as conductors and fully act as insulator, on and off devices. And they can used as an amplifier in the analog devices. Amplifier means, for example, if you observe the fan at your home, so at fan you have a, along with switch, one regulator also is there. By using that regulator, you can increase or decrease the fan speed. Not only you can switch off or switch on, you can also regulate the speed of the fan. That regulator is made by this pnp junction diodes. So like this we can control the, we can transist the power in different directions. That's why these are called transistors. Like that pnp or npn junction diodes used as transistors. So in this today topic we learn the, so semiconductors act as a rectifiers and transistors. Thank you for being with me. Thank you very much.